So welcome, ladies and gentlemen, to our lessons on inequalities and solving inequalities. What's an inequality? A lot of you already realize you've seen this sign, equal sign. I'm not even know this is not equal. And the first glance is looking at these other ones, right? So the first part of the lesson is just getting our definitions out. A lot of you already know that these are the greater than, equal to. And these are obviously less than, less than. But conceptually, they're weird, right? And we've been teaching you so much about how to solve equations, right? Which is related to the word equals, right? Basically, the left side must equal the right-hand side. These other five, you're not so used to seeing. So, the first glance at the handout that you're seeing is we're actually going to learn the fundamental properties of inequalities. And it kind of makes sense. And so, as you can see from the handout here, we have the first one, 8 is greater than 5. And let's just move this over. Okay, and this is true. And on the number line that I provided for you, and I'm off screen already, so it's for me. A lot of you know the number line, that's 8. That's 0, that's 8, that's 5. And clearly, anything that's above that, 8 is greater than 5, this is how we would look at it. So 8 is over here. And normally, if I were to include the 8, you put in a filled-in circle, right? And if you put the 5, you leave a also filled-in circle, right? So anything that's to the right of this is what we look at the number line. And this is true, right? This is true. This is also true. So anything towards where to make this understanding of greater than or 5. But now what we're looking at filling the chart is actually doing some operations of adding, subtracting, multiplying, dividing. Because what we're going to look at is how to solve these inequalities. And when solving, you have to usually have an unknown, right? So before we even get to the solving portion, let's follow through that table. Really, really easy. Right? So we're going to take that example, 8 is greater than 5, and we're going to add to both sides. And I think it says add 2 to both sides. So if we add 2 to both sides, we get 10 is greater than 7. Now the concern is not whether I got the math correct, whether or not this statement is still true. And this is still true, right? Everyone agree? That's still true. So addition doesn't seem to be having any problems. Right? Everyone okay with that? Pretty easy, right? A lot of you, if you skim through the package, it tells you the answer, what we're trying to get at. If we keep on going, still think that 8 is greater than 5. And this time I think it says what we're going to do is subtract 2 to both sides. We're going to subtract 2 to the left side, subtract 2 to the right side. And what do we get? 6, and then 3, and still 6 is greater than 3. And again, you don't realize I don't need to plot these points here, right? So it's just to help you to connect something algebraically and something visually, graphically. So subtraction is also still true. So moving right along, and hopefully the class will help me out. We're still going to take that 8 is greater than 5. And I think for the third example, it says multiply both sides by 3. Let's make that a little bigger. Can I get a volunteer? Tell us what we're going to get as our answers here? Any volunteer? Bridget?
24 and 13.
And I think you still agree that this is still the same, right? Everyone see what we're trying to do? This is still true. Thank you, Bridget. And divide both sides by 2. So we're going to take 8 is greater than 5, and we're going to divide by 2. Any volunteer want to give us the answer for this? Really easy. Saba?
4 is greater than 2.5.
4 is greater than 2.5. And it's still true. This is the whole point. Again, hopefully you're not memorizing the answers. So some of you are saying right now, what's the big deal? It's all adding, subtracting, multiplying, dividing. Doesn't seem to have any problems, right? So let's change it up. But before we continue, can I erase this?
Yeah.
Okay. So then now we're still doing 8 is greater than 5. I know you don't have to copy this is on your chart for you. And now it says multiply both sides by -3. And if you can't see that, I wrote that in blue. It might be small. Let's see how it goes. Different volunteer, give us the answer. Danielle.
-24, -15.
Aha. And notice, although magnitude, -24 is greater than -15, on the number line, -15 is here and -24 is here. And some of you are slowly realizing this is now true. If I were to write it like originally, to say this is false, it is incorrect. So to fix it, a lot of you are realizing this multiplication of a negative number flips the inequality. I was off screen, but hold on, I think you could hear me online. Anyways. So let's test it again with another example, right? So we still start with 8 is greater than 5. And what does it say for our last example? Divide both sides by -2. So divide by -2. Divide by -2. And I think everyone gets -4 and -2.5. But can I get a volunteer to make the leap? What sign should we put? Still put the greater than sign? Or put the less than sign? Any volunteer? Flora?
Smaller.
Yeah, smaller than, less than sign. Now this is true. So in essence, and you can see from the package here, and you might want to put a box there. I'm on screen here. If both sides of an inequality are multiplied or divided by a negative number, the inequality sign must be flipped or reversed. Does that make sense? The reason why I'm going to explain this is because it doesn't always happen. And what you're going to see now in our next portion is how to actually graph these inequalities on a number line. And this kind of graphing is a little too simple. In future and advanced functions, you're going to learn how to graph these equations with the inequalities. Okay, so regions of space. Before we continue, everyone okay? All right. So now that we've actually established that, let's talk about what they look like. And hopefully you have on your handout example 1, graphing of inequalities. So graph the following number line, pay attention to the numbering system. The numbering system, honestly, we talked about maybe in elementary school or middle school, how numbers kind of established. Some of you might know the whole numbering system or the natural numbering system. You definitely know what integers are. Rational numbers, even irrational. If you're not too sure, don't worry. I'll help you guys out with this. What you're supposed to take out of these next 6 examples is how they actually originated and how you actually draw it. For the first example, it's really stupid, it's really easy. It says x equals 3. So for the first example, it says x equals 3. X equals 3. And what is that going to do? On a number line, now I apologize, since I'm teaching it, I'm actually going to put my numbers above and or below, but you're more than welcome to actually do this. That's how you graph it. The filled in circle, right? A filled in circle means to include, right? And so that's for question A. Now for you in class, I think you can see it. So for some of you that are watching online, you might need to pinch and zoom in, but it'll make sense, again, if you have to ask me in class tomorrow. Let's go to question B. Notice this one says, x is not equal to -2, right? And where x belongs to the integer family. Now conceptually, what does that mean? It's like saying some number that's not -2. Well, if we were to ask you, what are all the possible numbers? You would be here for infinity, right? You'd be here forever. So the way that we get across this question, negative 2, we kind of indicate where it is, but say it's not included. So what are we going to do? And again, I can put it on top, if that's okay. I put an open circle. So for some of you that want to know a bit more enrichment, like what would that mean on a graph, let's just say? So let's just say at negative 2, we drew a sketch of a parabola, oops, like a parabola. But let's just say at negative 2, and conceptually this could be like, hey, I want to invite all my friends to this party, except Mr. Chen. So at negative 2, there's going to be a little hole there. That's what that means for this kind of example. So non-including, we graph the function or whatever, we put an open circle. One more term, a filled-in circle, and again, that's why I like it. I like it actually above. Non-including means to put in negative. Eric, you have a quick question? We'll talk about that in a moment, okay? Good question. So I think the question said where x is an element of integers. So this e, some of you have not seen it before, and we'll talk more about it in our next unit. But this stands for, it's a Greek letter epsilon, and it means is an element of, and I apologize if I'm off screen. Let's just move this over just a little bit because we don't need that garbage stuff. Now, a lot of students don't like this, even though that is what you say mathematically. So I teach my students this way. Belongs to. So this basically says x belongs to integers. Integer numbering set. So for example, you'll see in a moment, question C. Notice this is your first real true inequality. This is an inequality, right? Question B, x cannot be negative 2. It's an inequality because it's not equal to negative 2, right? So we put an open circle. But for question C, we have x is less than or equal to 4, where x belongs to the natural numbers. Now don't feel bad if you don't know what this is. I'll use blue chalk to show this. And that's at 4. I apologize, let's make sure our numbering system has any questions. That's B. So at 4, how am I going to draw this? One more time, natural numbers are counting from 0. What does that really mean? 0, 1, 2, 3, etc. I think a lot of you know that. But how would I show this? Question C, if I were to graph it, x is less than or equal to 4. Again, conceptually this is too easy. A lot of you would say the answer is if you were to write the algebraic sentence, well, Mr. Chen, we're going to start at 0, we're going to go to 1, we're going to go to 2, we're going to go to 3. And notice it says x is less than or equal to. Equal means include. But not 5, not 6, and not negative 1. Why not negative 1? Because it's the natural number system. So if I were to visualize what this means, for question C, and I'm putting this below, but that's okay, it would be a filled-in circle at 4, a filled-in circle at 3, a filled-in circle at 2, a filled-in circle, I apologize, my skill that, and a filled-in circle at 0, which I'll be filled in. And that's the answer for question C. Notice 4, 3, 2, 1, and 0. That's what that is. Saba.
If it's less than 4, couldn't x be like 1.5 or something?
Good, but notice what I'm stressing. I'm stressing the natural number system. Not real numbers, natural. So one more time, the natural number system. So let's do it. I'll explain this. This is actually a future lesson, but the whole numbering system, it's called set notation here. You start at 1, 2, 3, etc. Keeps on going. The natural summary system starts at 0. 1, 2, 3. Integers, it doesn't start anywhere. It starts negative 2, negative 1, 0, 1, 2. Rational numbers, all numbers.
What's that double?
Q, oh, whole numbers.
Okay.
Is the irrational. I think that's right. No, it's Q, it's bar and Q, sorry. And then R, all real numbers. Apologies, you guys can't see that. Let's move this over just a little bit. It doesn't really matter what these notations. These are hard. The Q is rational numbers. I can write that in. Rational numbers. And you'll see in a moment. Rational means like fractions, decimals, right? And then there's an infinite number of them. So you just got to be aware about the graphic. But what you're supposed to get out of this portion is that for the equal sign, filled in circle. For not equal to, open circle. And for question C, less than or equal to, notice not only you're putting in a dot or something, you're putting also a direction. What direction in this case? Towards the left. Why towards the left? Because we want to have values of x that are less than 4. But notice, good question, x belongs or is an element of the natural number system. So technically 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. And even your example was correct, 1.5 or 2.5 or 3.7. I just wanted to introduce this natural system here that plays a more important role later in some groupings. And in the real world, it's kind of like your understanding of like maybe data caps, right? When you have you downloaded so much content, and then once you reach like 20 gigabytes of data, whatever, then they start charging you more for each gigabyte over it, right? So that's the inequality. As soon as you reach it, then they'll charge you a different kind of rate. Make sense? Is everyone okay? Let's go with the next example and try it yourself for question D, E, and F. But we'll take those examples almost there. Just erase this. And this time the class is going to help us out. Notice for question D, E, and F, they're all x belongs to all real numbers, right? So I'll help you. Maybe I'll help you with the first one. Question D says x is greater than negative 4. Now conceptually, we're choosing numbers that are greater than negative 4. So first of all, let's get a volunteer to tell us what should I draw first on our number line if I wanted to represent this. Bridget.
Negative 4.
Okay. So I guess it's a 50-50 chance question, whether I use an open circle or a closed circle. So
An open circle?
an open circle is correct. Again, you can definitely draw it on your, because your handout, you can definitely illustrate however you want. I put an open circle, right? But now, which direction should we put the arrow? And this is slope, left or right? You have 50-50 chance. Bridget again.
Right.
Towards the right. And conceptually, this is what we're saying. Notice, graphing is sometimes easier this way than writing out the algebraic statement. Because you'd be here forever. You'd say, well, what numbers are greater than, negative 4? Like, should I start at negative 3.99999? Like, you go on forever. And then how about another number? Negative 3.9998. Like, oh my God, this is stupid. I would be listing numbers forever. This would be a horrible punishment. But notice what it says. We can't include because there's no equal sign. We don't include negative 4. So graphically, I understand it seems weird. But even if you were to draw it, it's like, can I maybe I make closer? Closer? You have to zoom in, magnify, take out your tablet. You know what's easier in mathematics? This understanding of an open circle at negative 4, even though it doesn't mean it includes it. And we draw it to the right. Before we continue, everyone okay? Grace.
For C.
Well, we're not at C, but
Sorry. But I think before I've learned that you could put like an arc instead of doing like all the dots. Can I do that, or should I just do that?
okay, so I'm gonna be honest with you. I think you're correct. I'll be honest with you. We rarely ever use a natural or whole number or integers or these ones. These 4 or whatever, these 5, they're just kind of used so that I can get the key. So to answer your question, I mean, if it did say integers, what I'm trying to also subtly explain is that these are what's called, these first 3 are called discrete. Like for example, a number on your maybe in your parents or maybe you have your own car, when you try to make up the volume, like there's no 23.7 volume, or it goes 22, 23, 24, right? So you're going up steps, it's called discrete. So each step, like lights are either on or off in this classroom, like lights off, lights on, right? There's no dimmer. There's no dimmer. You guys understand? So there's no flow of that real number. So to answer your question about the arc, maybe. It would ask you something simple like this. Oops, like your question for question C, the -4 and the natural numbers. So that if you were to graph it, I do want to see the dots. And there would be hash marks, like to show the numbers. -3, -2, -1, 0, 1, 2, 3. So there would be actually markings so that you could put the dots. Okay? Anyone else? Okay, for question E says, this lesson go longer than that. 1 is less than x is less than or equal to 5, such that x belongs to real numbers. So this one's a little tricky, and you have to actually get practice saying things like this. So one more time, this is 1. You read from left to right. In North America, we tend to read from left to right. So the way that you say it, I understand x is greater than 1. Don't get me wrong. I just think a lot of you understand that. X is greater than 1, but the way that this is written in this statement, 1 is less than x is less than or equal to 5. So some students, when they look at this, 1 is less than x, they internalize, well, x is greater than 1. I think a lot of you understand what I'm doing. I am saying the unknown first, and its relationship to, in this case, this number 1. In the second portion, you understand that x is less than or equal to 5. And again, we're choosing numbers that are less than 5, but includes that 5. Also, what I'm trying to subtly tell you is, by saying it conceptually, will help you to visualize what you need to graph. So I think there was a hand up that I actually wanted to share how to graph question E. Any volunteer want to tell me what I would draw first? Maria?
1 and 5.
1 and 5, yes, I did put a 5 there. I did put a 5 there.
And then you'd have an open circle at 1.
Open circle at 1.
And a closed circle at 5.
Nice.
And then for 1, the arrow would be facing the right.
So you know what we could do? I think you're correct. So Maria's saying, ladies and gentlemen at home in the audience, what she's saying, put the arrow here, put an arrow here. But you know what?
Oh.
Why don't I just combine the two?
Okay.
And this is the answer for question E. So notice what this is called? This is called a line segment. So some of you are slowly understanding. You already learned this in elementary school. And we'll do it up here in red. This is called a line. I don't know if you actually know what this is called, but this is definitely called a line segment. I want to know what this is called in the middle?
Semi-line?
Is incorrect. It's my first name.
I was going to say it's a ray.
It is a ring. That's not why I'm naming it. So notice it has a definite start, but it goes on forever. Whereas a line, that's why in grade 9 we asked you to graph straight lines. We asked you to actually put the arrows. It was actually tight because those lines keep on going forever. In this one, it has a definite start and a definite end. I mean, except this one is where we started at 5 and we went to 1, but not including 1, or vice versa. We didn't really start at 1, but then we definitely ended at 5. And that's how you're reading this inequality question E. Eric.
The way I look at it, I think, because if 1's less than x, and x is less than or equal to 5, that means 1, that means it can't be 5, right? Like, oh, never mind, we're looking for x.
Yeah, we're trying. No, good. This is a good question, Eric. That's why I tried to explain it to you. I broke this in English in 2 parts. So the 1 was less than x. I know it seems weird. That's why I said to you, technically, the way that you interpret this in English, x is greater than 1. Notice I'm reading this, even though we tend to read from left to right. I subtly try to show you, I'm reading it right to left in this case. X is greater than, going in this direction, than 1. And it is true. What numbers are greater than 1? Well, 2, 3, 4, 5, 6. Oh, I can't go to 6 or 7, even though it's true. There's another boundary that holds us to 5. Right? And some of you know this analogy also maybe with your cell phones, maybe you Snapchat or anything. You have a picture or something, but then all of a sudden Mr. Chen is ruining it, photobombing you. Ew, let's crop him out. This is Mr. Chen, I'm here at 6. Hi guys, it's me. No, we don't want you. Let's crop him out to 5 and keep your friends. So that's like cropping, right? There is a point of why you need to explain the inequalities to you, because the next lesson is kind of different. Saba, really quickly.
You mentioned that you were doing the dots above the line. Do we actually have to write the line segments like that?
Yeah, you can put them on the actual lines. I just, for teaching
But
purposes,
then,
so
like,
that
how
people.
can you tell if it gets like obscured by the regular line?
Yeah, so it's really up for you for your note taking. So if you want to, because in textbooks, and you'll see in the package, like, I just don't like it because it, for teaching purposes, like when students see this, it covers it up. I mean, you can do it. This is actually the proper way you're supposed to do it. But I like putting it above and above when I teach it. Okay, but when I'm doing multiple ones, I don't like drawing the number line over and over again. Grace, really quickly.
If we have an open circle with an arrow, is that also called an array?
Nice, yes. It was also, because it definitely had to supposedly start. So the question was, it was an open circle that for the ray, like in this case, this is a ray. Is this also, that's what Grace is asking, ladies and gentlemen. So this is a ray because it definitely had a start, but when I say start, it kind of approached -4, but not touch it. Right? And this concept of approaching but never touching, it's also your first glimpse to what's called calculus. Okay? But let's get to the last one, question F. Let's just erase this stuff. I'm running out of room here, so I'll put this underneath, that's okay. That was E. So question F, I think, was x is less than or equal to -2, and then notice a comma. X is greater than 0, and again, x belongs to the numbers. You can see how it looks on the screen, yeah. So think about it for a second, ladies and gentlemen, and then tell me what do you think we're going to draw. And I'll use blue chalk this time. Blue chalk. Saba, what do you want to say?
You need a closed circle at -2, and then you just draw an arrow like to the right.
To the right?
Yeah.
I don't
Left.
think so.
Left.
Towards the left for -2. Well, what about this portion?
No, but it's greater than negative. It's greater than 0 and like 1 and 2 and 3.
This is not greater than symbol. This is a less than or equal to.
Oh, right, my bad.
It's okay. Maria, you want to help her out?
You would have an open circle at 0.
Sure. And what direction will we draw the direction?
To the right.
Towards the right. So this is your first glimpse. And I know it's weird graphing. It's like, again, like at a buffet, there's all this food that's around you. But ew, right in the middle is something that you hate. Maybe ew, it's eggplant or something. Maybe you love eggplant, I'm just joking. The eggplant, but everything else, I'll touch everything else except for this portion, right? So this is like, again, a boundary of that statement. So we don't include it. So even though like -1 and -1.5, it's not true for this one, and it's clearly not true for that one. So this, even though it looks, we drew 2 rays, for this statement that we have, that's what you visually see. Right, so some of you understand also like,
How does that make sense though? There's like a gap in between.
I understand, so I apologize, eventually you're gonna learn this concept called union and intersect, but that's in grade 12. So I'm just trying to plant that little small seed so that some of you can see it. So I'll erase this because there's too much. Eric, really quickly.
So when there's a comma, it means like it's almost a separate question, right?
Kind of, right, exactly. And you'll see when we get to our next word. There's a whole point of why we're doing this. But let's just rephrase one more time what the important elements of this portion of the graphing was. Number 1, what the inequalities stand for. Right? Open circle, closed circle, and the direction that it goes on a simple number line, either left or right. Okay? Last but not least, let's turn the page over. Let's show you for this question here. Now, I apologize. We have to do some enrichment here because there's actually in the lesson, every grade level student needs to know how to graph these inequalities. So for us in enriched math, we'll do something what's called interval notation. It's a little easier. or a little harder depending who you are. So it's actually in the PowerPoint, but it's not in this package. But I want to get to the practice, and then I'm going to stop the video because this lesson got a little too long. But that's okay. And then I'll let you work away. So this practice question here, notice we haven't really taught you how to solve anything yet. So I'm going to help you with your homework, and I encourage you to do all these practice questions. And the answers are on the next page. The question says in the practice, solve each inequality, express your answer in interval notation, and graph the solution set on the number line. One more time, at home, if you're watching this video, if you don't understand the interval notation, you can wait till tomorrow. I'll explain. But I want to get to this part. Let's do question 2H. I think question 2H is good enough. To get you guys started. So notice what I'm trying to do, ladies and gentlemen. I'm trying to help you with your homework. 2H is as follows. And I'm just copying out the question, and feel free to follow along if you want. So negative 4x plus 24 is greater or equal to 0. So you still treat this like an equation. So whatever you do to one side, you must do to the other side. Everyone okay? So in this case, I think what a lot of you would do, well, any volunteer want to tell me? What would you do? Because we want to solve for x. Flora.
I want to move 24 to the right and change the sign.
Okay, hold on before we do that.
Oh.
Hold on. Hold on. So Flora said, let's deal with that 24. So I think what Flora's saying, and I'm going to repeat because, ladies and gentlemen, this is for you. Subtract 24 to both sides. And notice the inequality does not change, right? The inequality does not change. And again, if you're going to show that step, we'll do that in orange. 0 minus 24 is negative 24. We're almost there, Flora. What would you do next?
And then you divide both sides by negative 4.
So negative 4 divided by negative 4 divides out, so you get x. Negative 24 divided by negative 4 is?
6.
Thank you, 6. But notice Flora did the division by negative 4. So the inequality sign changes to?
It's still the same.
It's not still the same. This is the whole point of the lesson at the beginning.
Oh,
It flips.
Sorry, Maria?
It flips.
It flips. So it changes not from greater than or equal to less than or equal to 6.
Do you need that?
Let's do a check really quickly. Let's just say you did not do it. Let's just say you did x is greater than or equal to negative, x is greater than 6. Let's do a check. What's a number greater than 6, ladies and gentlemen? 7. I would choose 7. Don't choose 6, because 6 would be the solution if it was an equation. But this is an inequality. So check with if x was 7. Now you don't have to do this. You can do this in your head. If you were to check with 7, you plug this into the original question. You get negative 28 plus 24 is greater or equal to 0. And that's negative 4 is greater than 0. This is false. Which is why we did that at the beginning. When you do things to both sides, you can check. That's why the check for inequalities, some of you might just still do. But the whole point for this is to draw that. X is less than 6. So the inequality sign changes. Ladies and gentlemen at home. I'm not pointing at you, Miranda. Trying to make it entertaining for those people at home watching this amazing video. So, to answer the second part of the question, now graph it. Different volunteer? Hopefully someone that hasn't said anything yet. Any volunteer want to tell me, what would I draw for x is less than or equal to 6? What would I draw? No pressure. Audrey or Alex, Ellen, Danielle, Brandon? Audrey, what would I draw?
So you draw like a dot at 6?
Dot is it open or filled in circle or not filled in?
Filled in circle.
Nice! And the direction, left or right?
Arrow going left.
Nice! Ladies and gentlemen, look at that! 6, swan, visualizing. So this is how you solve it. Any questions? At home you can't answer because you're watching a video. Grace!
For all these questions, are we just gonna assume
Yes.
that it's all real numbers?
Yes, they're all numbers. Any questions? Ellen!
If the 4 was not negative, would
If the 4 is not negative,
we still flip it?
no.
Okay. Because we're not divided by a negative number.
Nice.
Okay.
Ellen just answered the question, so I'll repeat what she said. So Ellen asked, what happens if the negative 4 was actually just positive 4? Well, then you would not have that scenario, and then it would be fine. One more time, we did 3 things here, ladies and gentlemen. Number 1, learn how to solve the inequality. 2, when dealing with multiplication or division of negative numbers, the inequality sign changes. And 3, how to graph it. I'm going to stop the video right now.